Hello guys, today we are talking about the binomial expansion in A-level P1 lesson, okay? So let's move to our first part of the binomial expansion. So last lesson we also learned about combinations, right? So it's a basics for the binomial expansion, okay? So let's move into the first part about Pascal's triangle, okay? So what is a Pascal's triangle? You can find here. If you want to expand a plus b power of n, so like here, if we have a plus b power of 0, we can consider the answer is 1, right? Okay, so everyone's power of 0 equals to 1, right? So here, we can just written down a 1 right here, means there's only the coefficient equals to 1 for it, okay? And then we can draw 1, 1. And you can find the Pascal's triangles, every side of it is 1, 1, right? Okay, so left side and right side is both 1. So we can set a plus b power of 1 it equals to a plus b, right? So the coefficient of a and b is 1 and 1, right? So here means 1 and 1. And if you are trying to expand a plus b squared, you can set that is for a squared plus 2ab plus b squared, right? So you can find the coefficient of a squared, ab, and b squared is 1 to 1, right? So here is 1 to 1. And if you're trying to expand the a plus b power of cube power of 3, that is a third plus 3a squared b plus 3ab squared plus b cubed. But the power here, or the coefficient here is 1331, right? So here means 1331, okay. And a plus b power of 4, we can just written as a fourth plus 4, sorry, here is 4a cubed b and 6a squared b squared plus 4ab cubed plus a, sorry, plus b power 4, okay. That is a final expansion, okay. So you can find here that the coefficient is 14641, right? So here we written that as 14641. Then you can also try to observe the possible triangle. You will find that here obeys a rule that 1 plus 1 equals to 2, right? And 1 plus 2 equals 3, 2 plus 1 equals 3, 1 plus 3 equals to 4, 3 plus 3 equals to 6, and 3 plus 1 equals to 4. So you can find Pascal's triangle obeys a rule that each two adjacent numbers and their addition equals to the next row's central number, right? So here is for 3, right? So because if you want to just try to expand a plus b power 5, you can just written down the next row of the Pascal's triangle. That is called 1, right? And here's 5, and here is for 10, and here is for 10, here's for 5, and here's for 1, right? So we can just written down as a power 5 plus 5a power 4b plus 10a cubed b squared plus 10a squared b cubed, right? And then it's 5 times a b power 4, and then plus b power 5, okay? That is expansion equation right here, okay? And also we have the notation for the NCR, and we said before, like the NCR means the combination, and it means the method or the ways you can choose from n items, and you just want to pick r of them, okay? So here you can just written down as n factorial over r factorial times n minus r factorial, right? So last lesson we also talked about factorials, right? Because the factorial means like n factorial equals to n times n minus 1 times n minus 2 times maybe times 1 as a final term, right? So maybe for 4 factorial is 4 times 3 times 2 times 1, right? So here we can just written down also like nr using a vector form to represent for it. So it's very easy to show nr, right? Okay. So like for example, for 4, 2, you can say that is 4 factorial over 2 factorial times 4 minus 2 factorial is also for 2 factorial, right? So that is for 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1, okay? That is how we calculate it. And then you can just delete 2 on the both side, and you can find final answer is 6, right? So also means that if you want to choose 2 items in 4 items, we can say there are 6 methods of us to pick them, okay? And also here's a binomial theorem. And we can say a plus b power of n means that here we're choosing from n brackets, right? And we choose from n items, and we just want to choose 0b, right? 0b and na, right? So we can say here that is for nc0. Also, we can write down the vector form is n0, n power of a power of n, right? And also we can say if you want to pick out the coefficient of n power of n minus 1 times b power of 1, we can say we have to choose from n minus 1a in the brackets, right? And then we have to choose 1b in other bracket, right? So if we already choose about n minus 1a, we have one left bracket that is for b, right? So we can say here is for n1, a power of n minus 1, b power of 1, okay? And also for n2, you can just written down as n2, n a power of n minus 2 and b squared, okay? So that means how we can select from them, okay? So every time remember this, it's not very difficult, just using selecting method, just using a plus b power of n. Consider as n bracket right here. You want to choose like some of the a, some of the b, and just trying to uh like pick it, okay? So for example, like here, expand 2 plus x power 4. You can either using the Pascal triangles method, and also you can just try to choose using the like the form we said before. So using the Pascal triangle, you can say that is for 1, 4, 6, 4, 1 on the fourth row, right? Maybe here is for the fifth row, right? So we can say here that is for 1 times 2 power 4 and plus 4 times 2 power 3 x power 1 and plus 6 2 power squared 2 squared times x squared plus 4 times 2 power 1 times x cubed, right? And then plus 1 times x power 4. So you can just try to expand it as a final answer, okay? And also, if you want to using the combination to solve the problem, you can try to understand first. You can just consider 2 plus x power 4 as 4 2 plus x times together. So there are 4 brackets right here. So first, you want to choose only the constant value. So you can say we choose all the brackets as 2 in here. Okay, so we choose 2, 2, 2, 2. Okay, so we can say here is for 4 4, right? So we choose 4, 2 right here. So it's 2 power 4 and x zeros, right? Okay. And if I want to choose only for x right here, we can set here that is for x, right? So we can only choose one bracket right here. So it's for from 4 brackets, we choose only one bracket. Here is choosing x, and other 3 is choosing 2, right? So it's for 2 cubed times x power for 1. Okay. Also, you can just read the 4, 3, okay? They're both correct. You can set we select 3, 2 in the 4 brackets, and another is for x. Okay, so here is it. And also you can read that 4, 2 times 2 power 2 squared times x squared, and then choose 4, 1, 2 times x cubed, and then choosing 4, 0 as 2 times x, oh sorry, 2, 0 times x fourth, right? Okay, that is how we can calculate the final value, okay? Also, you can just handling or solving the negative values here is for y minus 2x cubed. So here a equals to 1 and b equals to negative 2x. So you can just written that as, so first is 3, 0, and it's 1 cubed, and then 3, 1, 1 squared, and negative 2x, 1. Okay, so here means from 3 brackets, we only choose 1 for negative 2x, okay? And then it's for 3, 2, 1, power of 1, negative 2x squared, and then plus 3, 3, and only for negative 2x cubed, right? So expanding it, you can find is a final answer. 1 minus 6x plus 12x squared minus 8x cubed, right? Okay, that is it. And here's an exercise for you. So you can just try to take your time for solving the problems, but you want to follow with me, you can keep on going, okay? So maybe for first problem, to find the coefficient of x cubed in the expansion of 3 plus 2x fifths. Okay, so you can just try to consider here, like first we can selecting 5, 5 here, right? Or you can also say 5, 0, that we only choose 0 brackets for 2x. So here is 2x and zeros. And here you can just set, we are choosing one bracket for 2x. So here's for 4 for 3. So it's 3 the power 4 times 2x 1. Okay, so here also 5, 2, 3 square, 3 cube times 2x squared plus 5, 3, 3 squared times 2x cubed, and then added with 5, 4, 3, and 2x power 4, and then 5, 5, 3, 0. Okay, it also gets considered as 1, right? As 2x power 5. Okay. But then trying to expand it. So first is for 3 power 5. The value here is for, I guess, is 3 power 5 is 243, right? The 243. And then phi 1. So C phi 1, we can just written that as 5 factorial over 4 factorial times 1 factorial, right? So it is 5. And for 3 cube is for 81, right? So 81 times 5 is 405. x also we also have to times 2, right? So it's 810, right? X and plus here 5c2 is for 10 and 10 times 27 times 4, right? So 4 times 27 equals to 108, right? 108. So it's 180, 1080 x squared, right? X squared. And 5 3 also is 10 and it's 9 times 8, so it's plus 720 x cube. And here is for 5 times 3 times 16. So it's for 80 times 3 is 240 x cube, x power 4. And then plus here is for 1 times 32, right? So it's 32x power 5, okay? That is a final answer of it. Also, you can use Pascal's triangle to solve it, okay? And for a second problem to expand 1 minus x power 4 fully, okay? So you can also using the same method. First is for 4, 0, and 1 power 4, and here is negative x and zeros, right? And then is for 4, 1, we just select for 1 negative x, okay? So it's for 1 power 1 cube times negative 1 power of x 1, and then plus 4, 2 times 1 squared times negative x squared, and then plus 4, 3, or combination for 4, 3, right? And then times 1 power of 1 times negative x cubed, and then plus 4, 4, and 1 power of 0, and it's negative x power of 4. Okay, that is for a final answer. So maybe for this problem, I will not simplify for you. You can just try to solve it on yourself, okay? But then for today's our lesson, hope you can understand for all about the binomial expansion is very important in the A-level lessons, okay? So that's for today's our lesson. See you next time. Bye.